This is Tim O'Brien reporting from Seattle on October 28th, 2025. And let's get to the news. First piece of news is a new open source project, MCP-Scanner. It's from Cisco, and it's Python code that's developed to combine their Cisco API scanning services with YARA rules. YARA rules are used to identify patterns, strings, binary code, and vulnerabilities, and LLM-based analysis. It's interesting because it's one of the first cases where we're using AI to scan for vulnerabilities. I've looked at the GitHub repository. It still feels very proof of, but it's interesting. It's interesting to see this space develop using AI to secure AI is something we're going to see a lot of. But this is relevant to you if you used generative AI, if you use ChatGPT 5, or if you use Claude and you ask it questions and it's going and doing tasks, it's interacting with model context protocols. So that's the security news. Programming language news, Go. So Go is a very interesting language. I know a lot of people who program in Go. They're much smarter than I am. And one of the reasons is they have to deal with something called goroutines-and-channels to do asynchronous event-driven work. A contributor named Samuel Bertha, I believe from France, has created a new domain-specific language called reactive programming. And if you want to see more of it, look at the show notes. You'll see a link, you'll see some code examples. But from my perspective as a non-Go programmer, again, I see this as an improvement. But if you're a Go programmer, you might disagree. Interesting to see what your feedback is. Look at the show notes for links. The last story of the day is in the weird bucket. It's a train that when it gets to the south of Italy, it's loaded onto a ferry and travels across the sea. This has been happening every day since 1899, and this is being challenged by a 13.5 billion euro bridge that's being built. This same pattern existed in Denmark and Germany until they were replaced by bridges, and there's a story covering the transition. Whether or not you view this as progress or the loss of some poetic antiquity, this train ferry crossing represents a vanishing of rail history. So if that's your thing, look at the show notes. You can see a link. Today's episode focuses on a post that I wrote called Your Code Might Outlive You, and that's a somewhat existential title for a blog post about software development. But it was a response to someone else's post. He was a professor, and he was talking about how he tells his students not to worry about code being very long-lived. It's just all going to be replaced eventually. And in the post, I'm challenging professors and academics who send that message that code is just ephemeral. What matters is the ideas. The reality is that in the industry, we face uptime requirements, budget and integration debt. Well-written code can literally outlive its creators and continue functioning for decades, and I've seen that in action. The core argument I'm making here is that there's a fundamental disconnect between what academia teaches students and what the industry needs. While universities prioritize prototypes and theoretical contributions, the real world is built on code bases that need to survive. Organizational changes, layoffs, which are happening more and more these days, platform migrations, evolving requirements. I'm advocating for a cultural shift where we, the programmers who listen to this podcast, value maintenance and reuse, recognizing that there is creativity involved in keeping systems running. That should get you a promotion just as much as creating something new. And what really drives this home for me is that this instinct to rebuild rather than repair is incredibly costly. Every time a developer says, well, let's just rewrite this from scratch, they're potentially throwing away years of bug fixes, edge case handling, accumulated wisdom. So when you do that, when you throw something away and you have to relearn those edge case lessons over time, that really introduces risk. So we need to relearn how to maintain, how to reuse, and how to take pride in keeping software operational over the long term. And that starts with how we teach programming in the first place. When I was an undergrad in Virginia, I skipped a lot of classes, to be clear. But I also spent a lot of the time that I was skipping classes in front of a computer. I was really addicted to programming. I wanted to learn everything I could about every flavor of Linux. And I got into this project with a professor named Dr. Stephen Jones, really smart guy. And he too was an accomplice in helping me skip classes because he would send notes to my professors telling them that I was working on important things. That didn't work, by the way. But I was on this project where we had to model a transferred electron oscillator. And it was a transferred electron oscillator that sat in the middle of a microwave cavity called a Karlstrom cavity. It was used in radio astronomy and on a couple satellites that would measure, say, the temperature of the ocean. But I was working on a really small piece of it, and that's what engineering is like. You're working on these massively interesting projects, but you're really just focused on one thing. The one thing I was focused on was some Fortran 77 code that we had that modeled the behavior of the transferred electron oscillator. It could generate a curve that would show what the output would be over the different frequencies it had to operate on. And this code was 15, 20 years old. And we had to run it. We had to run a lot of it in parallel. There were a bunch of new parallel processing systems coming out at the time. At UVA, we had a system called Mentat, which was new. But computing was still not focused on parallel processing. I learned Java. It was one of the first things I did. And I started using RMI. I created a wrapper around this Fortran code to execute it in parallel over 30, 50 nodes at once. But the key point is that I didn't go into the Fortran code and say, Fortran, I don't like Fortran, I'm going to rewrite it in Java. That would have been idiotic. Instead, we upgraded it a little bit. I think Fortran 77 to Fortran 90. We just ran the thing. It worked. And I would bet $1 million that if you go to that same group right now, the group that's working on TEO simulation, it's probably using the same code because it was complex. It wasn't worth rewriting. There was no performance benefit for us to rewrite it. If I did choose to rewrite it, it would have just been vanity, which I think fuels a lot of the rewrites. So the fascinating thing about a lot of scientific code is that once it's been validated, once you've proven through your experiments that your simulation matches reality, that code becomes almost sacred. You don't just throw it out and rewrite it because some new language is out there. The physics doesn't change. The math doesn't change. What changes is the hardware that it runs on and maybe some of the interfaces around it. When code solves a real problem and hasn't proven to work, it tends to stick around. And I've also seen that in industry. One thing I did not fully explore in the blog post is that hidden cost of rewrite culture. When a group of developers convince themselves that starting fresh is easier than understanding existing code, they're not just wasting time, they're destroying institutional knowledge. Every production code base, even if you think it's simple, it contains thousands of small decisions, workarounds for obscure bugs, edge cases, optimizations for specific use cases. When you throw that away, when you're guaranteed to recover many of those same issues under pressure in production, when they're most expensive to fix. I've seen this pattern repeatedly. A new developer joins a team, looks at a 10-year-old code base, declares it legacy, and pushes for a rewrite. 2 years later, that rewrite is handling maybe 60% of what the old system did. Maybe the old system is still running. The team has burned through their innovation budget, and customers are complaining about missing features. It's this habit that we have, or developers have, of looking at something and saying, I'd feel more comfortable if I created this from scratch. Because we really don't train our developers to read code that was written by other developers. We train, reward, and incentivize developers for creating. That's how you get promoted. So that's really the focus of the piece. It's been published for quite some time, so I have a couple of comments. Wallace Mann challenged my premise. He doesn't see disposability as coming from academia, but rather from the deadline profit pressure and the executive focus on short-term success. 100% agree. That is a good point. The fact that we have to have quarterly earnings reports and we're not really focused on multi-year progress. That pressure to ship fast and show quarterly results absolutely contributes to throwaway code. But I still maintain that academia sets that foundation. If we taught students from day one that code longevity matters, maybe they'd push back harder against those short-term pressures when they hit industry. And I'll put it this way. If you've ever hired a new grad, one of the things you have to wait for them to understand is we're not going to go do everything at once. We're not going to go rewrite the whole architecture end to end. There's some things over there. The code is gnarly and it's been running for 8 years, but leave it alone. That's not the thing we're trying to fix this year. Kunyu Feng, who I've responded to other posts that he made about education, he said he's of two minds about the article, arguing that software fads come and go, the good stuff endures, the bad stuff disappears. I partially agree. There's definitely natural selection in software. But here's the thing. A lot of good stuff disappears too, not because it's bad, but because somebody doesn't want to maintain it. A lot of bad stuff endures because it's too expensive to replace. Natural selection in software isn't as clean an analogy as we'd like to think. But again, I think it was a great comment. Thank you for leaving it. Vladas Saulis wrote about React, and it was an incredulous thing. How many times have you rewritten programs with it? New versions come, old versions get deprecated. This is exactly my point. The JavaScript ecosystem is the poster child for the disposability culture. I don't mind that so much. Ironically, I have a React app that I've been maintaining for 8 years. It has evolved, but I wouldn't say I replaced it from scratch. But notice how companies with React apps from 2015 are still running them. They might be on old versions that might be painful to upgrade, and in some cases they might be insecure, but they're still solving business problems. I think that the newer the framework, the newer the language, the newer the community, the more you're going to see rewrite culture. And I'm fine with that with React. For example, I just did an upgrade of a React app a few months ago, and I got to tell you something, using Claude Sonnet and using Claude Opus to do that made it possible for me to rescue and update and maintain. If I didn't have that LLM available, I would have had to start from scratch. Oakley Hall, a colleague of mine from New Jersey, who's one of the smartest people I know, made an interesting point about AI. He said, coding assistants let us easily interrogate nuances of code that we might otherwise be too impatient to discover. I like that perspective because that matches mine. AI tools could actually help us understand and maintain legacy code better. So instead of using AI to rewrite everything, we could use it to comprehend what's already there. And that is one of the most valuable things that I have been doing with LLMs. I look at code. Let's just be clear, like, your memory is not great. You might have written code 10 years ago and you want to rewrite it because you don't remember it. I've used Claude and Opus and GTP5 High to look at old code bases and say, tell me what I was thinking when I wrote this. And that, I think, is one of the keys going forward. I actually think LLMs are going to write a lot of code, but I also think they're going to help us rescue as much code as we write. NTTP, which I believe is a publication, left some comments that really resonated with me. They called out that rewrite the world people rarely pay out of their own pocket. It's someone else's money, 100%. They also made a great point about COBOL. It's considered boring, so rewrite happy developers avoid it, and it just keeps doing its job with minimal fuss. Sometimes being boring is a feature, and frankly, I wish I could program COBOL because I think those people are getting paid an amazing amount of money because no one knows COBOL. Patrice also suggested hexagonal architecture, and I believe this is from Alistair Coburn, who has just been a source of all good thoughts for multiple decades for me. That's where you isolate your core business logic from interfaces. That's absolutely one way to build code that lasts. Separate what changes from what doesn't. Good architecture principles matter. So take it back to what I said previously about that React app I rewrote. The React app that I wrote is part of a larger architecture that connects to an API server that's running on Express. It connects to a bunch of other libraries that are just plain old Node.js. And it talks to a database. That database schema is 10 years old at this point. I didn't have to rewrite that. I didn't have to rewrite the API. The API is still the same. It's evolving over time, yes, but I didn't have to hit a button and wipe it clean and start from scratch. And it's that separation that I think is important. I'm just going to say this, a lot of what I see in the front end Node.js culture reminds me of what Rails was in 2006 and 2007, where you just created one big monolithic thing and you had to replace it all the time. I think hexagonal architecture being more intentional about interfaces and the boundaries of subsystems, that's one of the keys to avoiding replace. Thomas Anderson shared that his community college night classes were taught by working professionals who brought real industry experience. That's exactly what I'm talking about. When your teachers have maintained production systems, they teach different lessons than pure academics. And I'm not saying anything bad about pure academics. We need people who are going to be thinking about the theory. We need people who are going to be bringing that process forward. But in my experience, having gone to engineering school, one of the things that we're missing is people who bring that 1,000-yard stare with them and say, oh, it's not that easy. One of the comments that stuck with me was from Mohammed Sakaja, who asked, how do you measure long-term code durability in practice? That's the million-dollar question, isn't it? We have metrics for performance, for test coverage, for complexity, but how do you measure whether code will still be maintainable in 10 years? Maybe that's something we need to figure out as an industry. And I think maybe it's a controversial thing to bring up, but there's a lot of layoffs today from Amazon, and apologies to those of you who are affected by that. I understand what you're going through. I think one of the reasons we have a rewrite culture is because the average tenure of developers is only 4.5 years. And I would also put another statistic out there that I don't know yet. I'd love to see some study. When you have a project, usually those developers are all moved at once. So I have seen this a number of times at a number of different companies. There's a team that's excited to develop something. They get to year 1, they deliver something in year 2, they maintain it in year 3, but priorities change and staff is moved to another project. So then you have this code that had so much excitement and so much activity sitting there waiting for a new team to show up and say, we got to rewrite this thing from scratch. And again, I could go on and on. This could be like a 14-hour podcast. And it could be full of all the things I've seen where a new team comes in and just wants to use a new version of JavaScript. So let's rewrite everything from scratch. Or a new team comes in and wants to change platforms entirely. And sometimes that's what you want, but it's usually not. Usually you're hiring people to do a job. You don't really care if they use the old code or new. So let's move on a little bit. So personal reflection. So I've spent time in both academics and industry. I've lived through these disconnects. In the lab, the simulation code was treated with respect because it had been validated. It had been validated through peer review. In my computer science classes, it was a whole different thing. It was like, start from scratch. Let's start from scratch. Just work on it for this assignment. We can move on. We can throw it out. Then when I got to industry, I discovered systems that have been running for decades. And I also discovered that in some organizations, most of the software that people are maintaining was not originally written by them. So it's a huge disconnect. And I think the other thing that we don't really comprehend is the cost of replacing a system, not just from cloud cost, right? So when you do a system replacement, you end up having to pay for an unavoidable double bubble. When you migrate from an old system to a new system, they both usually have to run at the same time for a number of months. And when you hear a team say, oh, it's easier, we're just going to replace it. The next question should be, okay, once you finish replacing it and testing it, how are you going to migrate it? Is that going to be a 3-month process? Is it going to be a 6-month process? Because here's what I've found. If someone says, oh, we're only going to need to run the old system and the new system for 3 months, you really have to think about how the economy works. Priorities could change. Staffing could change. Projects could be canceled. That 3 months can easily turn into 3 years. And then I have seen this, that one migration from old system to new system could turn into a old system to new system didn't really go how we had planned. So we have to run both of them. We're going to restart from scratch again. I've seen multiple times people do a rewrite decision on a multi-year project, a doubly nested rewrite, if you will. It's a second order rewrite. So if you're listening to this and you're thinking, what do I do? Here are the things I would suggest you think about. 1, before proposing a rewrite, spend some real time understanding the code. Try to talk to the people who wrote it, if you can. If the person who wrote the code still works in the same company, reach out and talk to them. Try to learn from their experience. Because without their experience, you might be stepping into a trap you don't even know about yet. 2, if you're teaching or mentoring, emphasize code longevity. Teach students to write code that someone else can understand 5, 10 years from now. And that seems silly because most people are only in school for 4 years. If you're writing an API, if you're writing a structure, it's important to design for the long term. Think about Emacs. Think about some of the things you use on the command line. That's code that might have existed longer than you. 3, take pride in maintenance. Reward people who maintain rather than rewrite. That is real money. There's a real skill in keeping a system running smoothly while evolving it to meet new needs. It's not less creative than greenfield. It often requires more creativity. And then 4, document your decisions. I remember when I was in like CS 201 back in Charlottesville, I was using Borland C++ at the time. And it was such an annoyance. I had to document everything. If I didn't write documentation for the code that I was delivering, I would get a C. And I was like, this is nonsense. No one's going to read this. Having worked with code that was written 20 years ago without documentation, I have to tell you something. Like, documentation is a must. These days, we're lucky. Our large language models are usually writing the documentation for us. In fact, that's actually a signal that somebody used a large language model because there's way more documentation than there would ever be in it than if a human wrote it. But it's important not just to document your code, but to document the decisions. Document the day-to-day decisions that went into changing the code. Document the edge cases. That is the thing, as developers, that I think contributes the most to rewrite culture. We don't document history, and it just keeps on repeating itself over and over again. So, some closing thoughts, because this is a relatively long podcast, and I'm still trying to keep them a little bit on the shorter side. The title, You Might Outlive Your Code, isn't meant to be morbid. It's meant to inspire responsibility. It's a little dire, but I am a little dire in terms of my personality. Every line of code rewrite has the potential to be running decades from now, solving problems for people we're not going to meet. And that's both a burden and an opportunity. Instead of treating your code as disposable, instead of just treating it as that wrapper that you just got at a fast food restaurant and throwing it out the window, what if we treated it like a craft? What if we built things to last? knowing that we're creating the digital infrastructure for the future, and knowing that we don't want people to have to rewrite this. We should solve it once, and we should take pride on the fact that we're keeping the profession professional. And let me explain what I mean by that. If we're professionals, we're going to be writing code that's going to last. And we're also going to be looking at the code our predecessors wrote. And don't get me wrong, if there's a problem with it, if it's bad code, throw it out. But if it's not, if it's functional, if it works, you should be taking what they did as precedent and improving upon it. And you should have confidence that whoever replaces you is going to do the same. I think if we did that, I think if as a profession we did more of that, I think we'd be less disposable. That's a little bit of a bold statement. But I think if we had more respect for our output and took more ownership of it as an asset, then I think that we as programmers would be respected as professionals. Instead, and I hate to say it, a lot of people just view programmers as replaceable assets. So that's the shift I'm advocating for. This culture of disposable needs to move to a culture of durability. And notice how I didn't get into the ecological perspective as well. We live in a culture that emphasizes throwing everything away every day. We can't do that anymore. It's not sustainable. I don't care what your politics are, left or right. We need to stop doing that with software. Okay, thank you for listening, and I hope you enjoyed it. If you did, let me know. If you didn't, also let me know. I'm looking for feedback. Please hit or subscribe if you found this entertaining or interesting. We're on Apple Podcasts. We're on Spotify. We're on everything. Every podcast platform you can possibly name, we're probably on it. And again, I want to thank you for listening. I'm going to go rewrite some huge software projects from scratch because that's how you get promoted. And I hope you have a good day.